So as we move into Unit 1 walkthrough, we're going to now do question 9, 10, and 11. So question 9 says solve the equation. Again, identify excluded values as appropriate. Again, excluded values happen if the variable is in the denominator. So if we look at this problem, the variable is y and it is not in the denominator, so we don't have to identify any excluded values. So the catch now is to solve this equation, one of the easiest strategies is to get rid of fractions. So that's how there's a 9, a 4, a 9, and a 5. So what I'm looking for is a common multiple between a 9, a 4, and a 5. So if we look at this, they don't have any common factors in common. So really what we would do is just multiply these three numbers together. Well, 5 times 4 is 20. 20 times 9 would be 180. So I'm feeling like the least common multiple would be this 180. So what I want to do is multiply each side by this 180. Now, if you want to, you can multiply it by each fraction one at a time. You can multiply by 9, multiply by 5, and then multiply by the 4 if you want to do it one at a time. This will do it all at once. So on the left side, I have, I'm going to multiply this whole left side by 180. So this 2/9 y plus this 1/4 goes here. So I'm going to multiply this side also by 180. So it's going to be 1/9 y plus 6/5 here. Let's keep it kind of the same. So what I want to do is multiply by the 180 goes through the parentheses. So this 180 goes through there. Now, the reason we multiply by this 180 is we wanted to cancel with the denominator. So notice that 9 does go into 180. That's this over here. That's at 20. So what we're going to do is multiply 20 through the parentheses, or through the 2y here. So 9 goes into 180, 20, and we're going to multiply 20 times 2 times y. That's going to be 40y. But then we're going to multiply the 180 to the 1/4. Notice how the 4 is going to go in here and cancel out. So notice how that's just going to knock out the 4. That's going to leave me the 9 and 5, and that's going to be a 45 out here. 45 times 1 is going to be 45. So since that 4 canceled out, that left me the 9 times the 5, since we used all these to make the 180. Again, you can also use your calculator for that. So now I'm going to apply this 180 times 1/9. That's how the 9 is going to cancel with the 180 and give me a 20 again. 20 times 1y would be 20y. And they're going to multiply 180 to the 6/5. Notice how the 5 is going to cancel out there. In doing so, that's going to leave me this 9 times 4, which is a 36. But I still got to multiply 36 times 6. So if you have your calculator, you can multiply 36 times 6. I didn't make it handy. So 18 plus 3 more, 321, it'd be 216. So it's going to be 20y plus then this 216. So we got rid of fractions because that's an easy strategy to make this look a little bit easier. So that's kind of part of the simplifying process, is to also like remove fractions. And we use the least common multiple or least common denominator for that. So I want to pick on the little guy now. Since the variable's on both sides, the little guy is the 20y. So I'm going to subtract a 20y here as long as I subtract a 20y over here. So if I simplify, I'm going to have a 20y comes down, the 45 comes down, and this 216 comes down. Because the 20y and the negative 20y are going to zero out. So the next thing I can do now is to solve for y is get rid of the constant, the 45. So I want to lose the 45 over here. So I put a negative 45 there, and I put a negative 45 over here. So when you add a positive 45 to a negative 45, they're going to zero out. So I have this 20y, and what's 216 take away 45? So I get a 1 there. I got a borrow, that's a 1. This is 11. So 171. Yeah, 171. So from there, I want to solve for y. I have to make the coefficient disappear. So I got to divide by the coefficient. So I want to divide by 20 as long as I divide this by 20. So I have 171 divided by 20. Now the math is getting a little deep here. So I'm going to have to start engaging my calculator, it looks like. So anyway, I have 20 into 171. Well, if I ignore the 0, 2 is going to go into this like 8. So it looks like 8 goes here. 8 times 20 would be 160. So my remainder would be 11. So if I add a 0, bring it down, put my decimal point there. What times 20 gets me close to that? That'd be a 5. 5 times 20 would be 100. Come down with a 10, add another 0. So 20 goes into 100. That'd be 5 times. So it looks like that's going to be 8.55 if I use decimals. If I'm leaving it as fractions, you could also leave it as 171/20th if it's not asking for a decimal. So that fraction doesn't even reduce. So question 10. Solve the equation, identify any excluded values as appropriate. So I'm going to pause my video for a second and we're going to get a calculator out this time. So question 10, we want to solve this equation, identify any excluded values if there's any. Again, the only time there's going to be an excluded value is if the variable is in the denominator, and it's not. So what I want to do, again, is I want to get rid of fractions, and I can do that by multiplying by the LCM. So again, the LCM here looks like it's just going to be this 26 times 5. So I'm going to multiply 26 times 5. That's going to give me this 130. So 130 is going to be the LCM. So what I can do is multiply each side by 130. So I'll put 130 over here. And then in parentheses, I'm going to have this 5/26p plus 7. And then over here, I'm going to have 130 times then 1/5 p. So again, the reason we multiply by 130 is to cancel out with this 26. Notice so that 26 times 5 gave me this 130. So if I cancel a 26 into the 130, that should give me a 5. So 5 times 5p should be 25p. So again, if you wanted to, you could use your calculator and divide 130 by the 26. And it should give you the 5. It's the same thing. So then I multiply the 130 times the 7. So there's no canceling there. So the 130 has to multiply to the 7, and then it doesn't get knocked out at all. So 130 times 7 gives me 910. Over here, what I want to do is multiply the 130 times the 150. But notice how this 5 is going to cancel with this 130. That's going to leave me this 26. So the 26 times 1 is going to be 26. That's going to be 26p. So from there, I want to solve for p. Since it's on both sides, we pick on the little guy. The little guy is actually the 25. So I subtract the 25p here, as long as I subtract the 25p over here. So what I do is combine my like terms. Those zero out. I get a 910. And over here, 26p lose 25p would just leave me 1p or p. So that's actually solved. So p would equal 910. That would be the solution. So question 11 it says find the total resistance in a parallel DC circuit with two branches rated at 15 ohms and 6 ohms respectively. So we have this formula that total resistance is defined as R1 over RT equals 1 over resistor 1 plus 1 over resistor 2. So in our problem, we have R1 is this 15 ohms, and this R2 is this 6 ohms. It doesn't matter who you call R1 or R2. So what this turns into then is 1 over RT equals then 1 over 15 plus 1 over 6. So if I want to find the least common multiple here to get rid of fractions, the multiples of 15 would be 15 and then 30. The multiples of 6 would be like 6, 12, 18, 24, and then 30. So I'm feeling pretty good that 30 kind of jumped out at me as a common multiple there. So what I want to do is I want to multiply each side of the equation by 30 to get rid of fractions. So I'm going to multiply this side by 30 as long as I multiply all this by 30. So I kind of didn't want to write the problem over. So this is going to be 30 over RT. And that's going to equal then, notice how this 15 is going to cancel into the 30 with a 2. 2 times 1 is going to be a 2 there. And then you multiply 30 times this 1, 6. The 6 is going to go to 35, and then 5 times 1 is 5. So I can rewrite this then as 30 over total resistance, if you will. And 2 plus 5 is 7. So I can actually make this a fraction by putting that 7 over 1. So if we have a fraction equal to fraction, that's called a proportion. In proportion math, we are allowed to cross multiply. So what I have then is 7 RT, 7 times the total resistance, and 30 times 1 is 30. So if I divide both sides by 7, so 30 divided by 7, that's going to give me this 4.2. But notice the directions say round to the nearest hundredth. That's 2 places past the decimal. So that's where the 8 is. But notice how there's a 5 next to that. So 5 tells me to move that 8 on up to a 9. So 4.29 ohms would be the total resistance in this problem. So that's one way of doing it. You may find other ways to solve these. This is the way that I fell into that at this time. So that's takes you through 3 more questions.